Um, if we have a few minutes, I was gonna ask you a question about the quiz we just did on 12,
Sure. Yep.
but
Yep.
I can wait till after class if you prefer.
We have 7 minutes. So if you think that it could be answered in that period of time, we can go for it.
All right, although I didn't do very well on my first try on quiz 12, I was very confused about question 1 on the first time I tried it.
Okay.
Um, I got 5.78 and they were saying that the answer was negative 5.78 and I don't understand how they got the negative in there. I don't know what I did wrong.
Let's see here. Quiz 12, you said?
Quiz 12, yeah. The first question, I mean, there's several other ones I missed on my first try, but I know what I did wrong because I reworked them and figured out how they got the answer. But on the first one, I didn't get how they got a negative out of that.
Okay. Let's see. It should be negative. Let's see here. See if I can open up my whiteboard. Can you see my whiteboard?
Uh-huh.
Okay. And is this the problem that you're talking about? Oh, my pen needs to be turned on. Or negative 25 minus 32a is equal to 160.
Yep.
Yep. Okay. And how'd you start?
I did plus 25 to both sides.
Okay. I agree with that.
Okay. Which leaves you with 32a equals 85.
Uh-huh. Or negative 32a is equal to 185. Uh-huh. And it's negative
Oh, maybe
because,
that's what I did wrong right there.
yeah, that
But
might do it.
because you considering that minus as a negative 32,
Yes.
and that probably would have okay. That yeah,
Mhm.
the signs change sometimes when you're
Mhm.
pulling one number off of one side. I am okay, so if it was negative 32 divided by 32,
Yeah.
you
Divide
get
both
a
sides
negative,
by.
you get a negative. Oh, you have to divide by negative 32.
Yeah, because
Okay,
you want
okay, wait.
a to remain on
Negative
the left.
32 divided by negative 32
Mhm.
equals 1, which is just an A.
Yep. And that should give you negative 5.78.
Let me look at, how many, 185 divided by 32. Oh, wait, it'd be 185 divided by negative 32.
Yep. Yep.
Okay, so I'm gonna write that down. There was another one on the second try I was gonna ask you about, but if we're running out of time, we can do it after class. Because we only have a few minutes, but
Was it another negative sign issue? Or was it something?
hang on a second. It's okay. Let me see if I can flip this real quick so everybody's not, I'm not holding everybody up here. So on my second try, um, the last one, it's got the two answers.
Yes.
So when I got R equals 32.4 or whatever, you got to round it up to two decimal places. So I put 32.25
Mm-hmm.
for R equals.
Mm-hmm.
And then on the other part, it's 1/8 times 32.25. And I got the I equals part wrong because I used the rounded version to get the I, the
Right.
second part. And so they said that the answer was 4.03
Mm-hmm.
and I put 4.06.
Mm-hmm. Yes.
Well, we have to round to get the correct answer for R. And then we got to go back and get the unrounded version just to get the second answer.
That's actually more common than you might think. Each answer, like you want to round your answers to 2 decimal places, but if you're going to do something with that answer, so if you're going to multiply it by something, divide by something, then you generally want to do further calculations with an unrounded answer so that it's more accurate. Because anytime you round it, there's a certain amount of error involved in the problem. And so if you put that rounded answer, if you multiply by it, then the multiplication or the division will amplify the error. So it's pretty common to need to use the unrounded answer to do further calculations.
Yeah, I got
So-
everything else right on that
Mhm.
one, on that try, except for that one.
Except for that one. Mhm.
Yeah. Everything else was fine,
Mhm.
except for that one, because of a rounded answer at
Because
the
of the
end
rounding, yep.
to find the I.
Yeah, it looks like you did everything else right.
Yeah,
Mhm.
and I'll rework it again so I get a better score, but because I like to keep my scores up high, but I just, so if we have something like that on a test, you can't use the rounded answer to find the second part of that equation.
You can't generally, and this is what I was doing on the previous test. I'm looking at the time. We will start momentarily. Generally on tests, I'm not as particular about rounding. I am going to go back and give points. If there was a rounding error, at least give most points. For quizzes, due to the fact that you can redo them, I'm not as lenient with those, so I'll let you go back and redo due to rounding. Do one that will count a wrong due to rounding error, but for exams, I generally look over those, and if there is a rounding error, I will count off. I will either give full points back or give most points back for that.
Now, I never even thought that to be a problem. Because I know if you're doing like multiple steps on an equation, and I had this in my last math class,
Mhm.
you want to use the longer version as you go through the steps until you get to the very end. But I never thought it would affect a problem like that where you have 2 different answers in it. One was right, the first one was right, but you got to use the first answer to get the second one. I never thought that would be a problem.
Gotcha. Yeah, it does show up, and if you or anybody else goes on and if you take the second part of this class, Tech Math 2, that's going to show up a lot more. Because there'll be a lot of paired answers or a lot of things that you have to use a rounded answer. You have to enter a rounded answer and then go ahead and use that to find other parts of the problem.
Yeah.
Okay.
Okay. That's all I wanted to ask. Thank
All
you.
right. Great. Well, welcome everybody. I just realized that I don't have the PowerPoint quite prepared, so let me jump on and grab that real quick. And then we can start. As I'm sure you know, this is our last lesson before the test. So I think I talked about this last time, but Thursday next week, we're going to have a test on section or on all the test 2 material. I just today posted the test. So you should be able to, if you want to take it early, then it should be accessible for you at this point, as long as you use the UJA app. Let me know if there are issues with that, because I know sometimes there have been issues in the past with getting in. If you want to take it during class, then of course that will be done next week. During our normal class time on Thursday. Any questions on that? Okay. Great. Almost ready. Should have been a little more prepared for this. Apologize. Go. We will, as mentioned, spend Tuesday next week reviewing. There is a review posted for your practice purposes. So go ahead and begin studying for that. Come with any questions. And yeah, we will we'll use that as our review. My iPad is being very slow at the moment. I'm sorry. It's not wanting to pull up what I just told it to do. Oh, goodness. Well, I put it in the wrong place. There it is. Nope, that's not it. So sorry, I don't know what the tech issue is here. Why it is not bringing it up? Maybe it's just being slow. Well, maybe we'll try something different then. Okay, yeah, hopefully we'll try it differently. Hopefully it will pop up soon. There it is. Great. So let's start. And hopefully my iPad will decide very soon that it wants to work with me. I love it when it does this. So we're going to talk about some different types of equations today. We're going to solve more of those more complex equations that we talked about last class period. And again, they're not going to get overly complex. This is not a formal algebra class, but we do want to add some more complexities so you can solve slightly more difficult problems. And we're primarily going to talk about more simplification techniques in order to solve those, quote, simple type equations that we did before break. Let's start there. Last time we did this, we had expressions that looked like this: 7 times 3x, where we took a constant and multiplied it by a single term. And we noted that we could multiply these two together. 7 times 3x is 21x. Okay. We want to expand that to multiplication by a, say, polynomial with multiple terms. So 8 times 4x plus 1, for instance. If we are given something like this, then we can multiply the 8, that term out front, by both terms that are being added together within the parentheses. And then we can multiply each of these terms individually as we were doing last time. So 8 times 4x is 32x, and then 8 times 1 is 8. This is called the distributive property. Distributive property. And it is used frequently in algebra classes. We're essentially taking that term out front and we are multiplying it by each term within the parentheses if I have a sum or a difference within the parentheses. This is another way that we can simplify one side of the equation or another before we solve. And it's often one of those first steps, just like multiplication was one of the first steps that we did. Okay. So let's do a few practice problems using that property. Let's say we are asked to solve 2 times 5x plus 6 is equal to 220. I'm noticing that I have a set of parentheses on the left-hand side indicating multiplication of that 2 by whatever's in the parentheses. Before I solve this, I want to simplify that left-hand side. So I'm going to apply the distributive property. I'm going to take the 2, multiply it by the 5, and take that 2 and multiply it by the 6x. I'll go ahead and write that out. 2 times 5 plus 2 times 6x is the left-hand side. Okay, that's still equal to 220. I didn't do anything to the right-hand side. And now I can deal with each of these terms individually. I can multiply. 2 times 5 is 10, and 2 times 6 is 12, and the x just gets tacked on to the end there. It is equal to 220. So we have removed the parentheses by multiplying. That is our simplification process for the left-hand side. This is now a simple equation. So I can focus on PEMDAS or PERMDAS if you prefer, and work backwards to solve this equation. So I'm going to start with the addition subtraction. It's like there is a 10 being added to the x part. So I'm going to undo that by subtracting 10. Do exactly the same thing to the opposite side. That leaves me with 12x on the left is equal to 220 minus 10 is 210 on the right. Okay. And now as a last step, I can move on to multiplication division. I'm going to do the opposite of multiplication on the left-hand side. I can do that as long as I do the exact same thing to the right-hand side. So that leaves me with 1x on the left is equal to 210 divided by 12 is 17.5. Do that in your calculator. That should be what you get. So x is equal to 17.5. Questions on that so far? Okay. Great. Let's do the one on the right. I am going to focus on the parentheses first. Okay. So the one on the right, it looks like I have a -5 and it's being multiplied by a sum 2n minus 6. So I'm going to start by distributing that -5 over the parentheses. So on the right-hand side, I have -5 times 2n minus -5 times 6. Or you could say plus -5 times a -6. Either of those should get you the correct answer. Okay. And then I can write the left-hand side as is 31 plus 4n. There are no parentheses on the left-hand side, so I'm not going to distribute. I can now multiply the terms on the right. -5 times 2n, negative times a positive gives me a negative, -10n, in fact. Here it appears that I have a double negative. I can remember that a double negative becomes a positive. You can also check that in your calculator. -5 becomes a plus. 5 times 6 is 30, so this becomes plus 30 is equal to 31 plus 4n. Okay, so we have taken care of our parentheses. That is typically a good place to start, is to simplify one side or the other by multiplying to eliminate the parentheses. Now that we've done that, we can note, well, where are the variables? Where are the variable terms? Looks like I have a variable term left and right. So my next step will be, let's get all of those on the same side. Maybe I'll move them to the left-hand side. Maybe I'll put all the variable terms on the left, which means I'm going to add the opposite of 10n, or of -10n. -10 plus 10 becomes 0. That is my goal on the right, is to get rid of the 10n. I'm going to add exactly the same thing to the left. So that leaves me with 31 plus 4n plus 10n is 14. And on the left is equal to 30. So great. We now only have n's in one place. So we can now treat this as a simple equation. I'm going to go to PEMDAS and I'm going to focus on addition first. Remove that 31 from the variable side, do the opposite of addition. So that leaves me with 14n is equal to 30 minus 31, which is, I believe that is a -1. Well, come on, little guy. See, this is the issue when I use PowerPoint. Sometimes it will not let me write as low as I want it to. There it goes. Okay, we're awake now. 14n is equal to a -1. Come on. Don't understand this. Okay, we're almost done with this, and then I'm gonna try the my normal method again, because this is not working very well. 14n is equal to -1. There we go. And then as a last step, I can deal with multiplication. I'm going to divide left and right by 14. There we go. -1 divided by 14. Put that in your calculator and you're going to get -0.075, or 0.07 rather. Negative 0.07. There we go. We got there. Questions on that? Okay. Well, I'll tell you what. How about I give you one to work on then, while I try to fix my my PowerPoint. Okay. Let me do this. Let's move on to this problem. There we go. And I'm going to give you a hint on this one. And then I'll let you see if you can work through the details. There is a negative sign out here. It doesn't, there is a set of parentheses, but I have to note that there is technically a number being multiplied by that set of parentheses. Whenever you don't see a number beside the parentheses, you can assume that it is 1. So to begin this problem, you want to start by distributing that -1 over the parentheses. And then you can proceed with the steps that we were doing on the previous one. Okay. So as a start, why don't you attempt this one? Let me go see if I can resurrect my other form of this PowerPoint. So take a couple minutes to work on this. Hmm. Okay. Good. Keep your answers coming in. I'm just gonna write some things down. I've got somewhere with this PowerPoint. -12a. I'm going to distribute the -1. Good. -1 times 3. -1 times 2a. Great. So we've got -77. So you put some -12a. minus 3 minus 2a. So that should be what you get after you distribute. Okay. And now we're going to find that there are two variable terms on the right. When I have the variable terms on the same side, I want to combine terms on the same side, I don't change the sign. I just add them. Negative 12 minus 2 is a negative 14a. And then I still have the minus 3. So this gives us a simple equation. I can now do that reverse PEMDAS, or PEMDAS. And I can do the opposite of subtracting 3 by adding 3. So it gives us negative 74 is equal to negative 14a. There we go. And then as a last step, I can focus on that multiplication. And I do want to divide by a negative 14, not a positive, because I want what remains on the right to be 1a or just a rather than negative 1a. Negative 74 divided by negative 14. Negative divided by negative is a positive, so that gives you 5.29, as you all were telling me in the chat. So nicely done. Any questions on that one? Okay, sounds good. Well, just for the sake of showing the difference between some of the forms of these equations with parentheses, let's go ahead and do a few practice. I will do a couple and I'll let you do a couple. Now that the PowerPoint is working. Makes it easier. So let's do number 1. 7 plus 8 times a minus 3 is equal to 63. Okay. If I am faced with an equation that looks like this, the first thing I'm going to do is focus on any parentheses that are present, which indicates multiplication. I'm going to simplify that left-hand side. I am not going to multiply the 8 by the 7. The 7 is outside the parentheses, but I am going to multiply the 8 by the a and the 8 by the 3. So that gives me 7 plus 8 times a minus 8 times 3 is 24 is equal to 63. So great. We took care of the parentheses. Once I do that multiplication, I can drop the parentheses. I'm now going to see if there's any simplification that I can do left or right. And it appears that I have constant terms left and right, and I want to include the sign before those terms. So I can take 7 minus 24, and I get negative 17, and I add those together. Plus 8a is equal to 63. Great. This is now a simple equation. So I can proceed with the reverse of my PEMDAS. Start with undoing any addition or subtraction. So I have negative 17 being added. I can add positive 17 to both sides. And I do that because negative 17 plus 17 is 0. So that leaves me with 8a on the left. 63 plus 17 is 80 on the right. I think we've worked with this equation before. I can now move on to multiplication division. I can do the opposite of multiplication, which is division. Leaving me with 1a on the left is equal to 10 on the right. So a is equal to 10 would be the answer to number 1. Questions on that one? Okay, let's go ahead and do number 2. And number 2 kind of illustrates the difference between this parentheses with a sum or a difference in them and parentheses that have all multiplication. Okay. I am going to start with the parentheses, just like the previous problem. And I'm going to begin by multiplying. So if I have parentheses right next to each other, that indicates that these two are being multiplied. So I'm going to take 14 plus, we're going to multiply those constant terms and then multiply p times p. That's how you would deal with that one. 14 plus 16 times 3 is, I believe it's 48. Yes, that's what I got earlier, 48. And then p times p is p squared is equal to 460. Okay. This is now a simple equation. I only have a variable in one location. So I'm going to start by reversing PEMDAS. I'm going to start with any addition, subtraction, start undoing those. I can subtract 14 because that undoes the addition of 14, giving me 48 p squared is equal to 460. Okay. And then I can move on to multiplication division. I am going to, before I deal with that exponent, because exponents come after multiplication division here, I am going to undo the multiplication. I'm going to divide by 48. Thank you very much. You're correct. It is 446. 446. Forgot to do the subtraction. Okay, so we'll divide by 48, which gives us p squared is equal to, what would it be? 446 divided by 48. So that extremely long number, 9.29166666666, etc. About 9.2917. And then we don't have p by itself, we have p squared. So as a last step, we can undo that exponent of 2 by taking the square root of both sides. Back to the calculator. Let's take the square root of this, and we get 3.05, it appears, for our solution. About 3.05. We can now round because this is our final. Any questions on that one? All right, sounds good. Why don't you try number 3 and 4? Take a few minutes to work on these two. And again, they kind of illustrate the difference between the differing ways that you'll see parentheses. Sometimes you'll need to distribute, and sometimes you'll just need to multiply. Put your answers in the chat for these. One of them you should get a whole number, or rather an integer. The other you'll get a decimal that you'll need to round. Mhm. Okay. Give another minute or two on these. Okay. Okay. Mhm. All right, awesome. Well, if you're still working, feel free to keep working. I'm going to work through this one. We can note that if there is a subtraction preceding any parentheses, then we can treat that as a -1 being multiplied by the parentheses. So I can take that -1 and I can distribute it over the parentheses to begin. So we have 5f, and then -1 times 3 is a -3. -1 times a -2 is a +2f. So negative times negative gives us a positive, is equal to -17. Okay. So we have eliminated the parentheses. That's a good first step. The next thing I'm going to do is I'm going to look at the two sides and determine if there's anything I can combine. I do have multiple variable terms on the same side of the equation. I can take 5f and I can add that to 2f. Those are like terms. 5 plus 2 is 7f. So it leaves me with 7f. And then I still have the -3 is equal to -17. Great. I've taken care of the simplification. I can now consider PEMDAS or PERMDAS. And I can go backwards because this is a simple equation. Start with undoing my addition subtraction. I'm going to add 3 in order to do the opposite of subtracting 3. That leaves me with 7f. It's equal to -17 plus 13 is a -14. And then finally, to get what you all were telling me was the answer, I can note that there is a 7 being multiplied by f. So I'm going to move to multiplication and division, and I'm going to divide by whatever that f is being multiplied by. So if I'm moving something from one side to the other, if I want to leave f alone or leave f by itself on one side, then I have to focus on the thing that f is being multiplied by. So I'm going to divide -14 by 7. -14 divided by 7 is a -2. So f is equal to -2 is the solution to 3. Are you all right with that? Questions on number 3? Okay, good. Yes, you have a question, or yes, you're all right. Which is it? All right, great. I thought that was what you meant. Let's go ahead and do number 4 then. Make sure I wrote that down right. And again, this kind of illustrates the difference between the types of parentheses you're going to find. Didn't write that down very well. On the left, we have a sum within parentheses, and on the right, we don't. On the left, I'm going to distribute. I'm going to take the 5, multiply it by the 7, and multiply it by the r. 5 times 7 is 35. 5 times r is 5r. So I've taken care of those parentheses on the left. On the right, we don't need to distribute. We're just going to multiply. 6 is next to a single term polynomial on the right. So 6 times 15 is 90. 90r. Make sure I did that right. Yes. Okay. So no distribution needed on the right. We don't multiply the 6 by the 15 and by the r. We just multiply the 6 by the constant 15. Now that we have that, I can note that there are variable terms on 2 different sides. I don't want 2 different variable terms. I want to have those all on the same side. So you can choose to collect all variable terms on the left or to collect them on the right. I think I'm going to collect mine on the right this time. So I'm going to undo the addition of 5r by subtracting 5r. I can do that as long as I do exactly the same thing to the right-hand side. That leaves me with positive 35 on the left. 5r minus 5r is 0 on for the variable terms on the left. That's my goal. That's for that to sum to 0. And then 90 minus 5 is 85r. Okay. So I am thinking about PEMDAS here. So this looks like a simple equation. I've already done my addition subtraction, or really there isn't any addition subtraction left to do now that I have the variables on the same side. So I'm going to move to multiplication and division. I'm going to undo that. There's an 85 being multiplied by r. So I can do the opposite of that, divide both sides by 85. And this is one thing you do have to be kind of careful about is we're taking, in our calculator, we would take 35 and divide that by 85. The order of the division does matter here. We want to write the 35, the numerator first, and then write the 85, the denominator. If you do that, you should get about 0.41 is my R. Any questions on that? Okay, sounds good. Well, we're going to change gears a little bit then. And we're going to start talking about some applications. We're not going to get, like I said, super complicated, but generally the goal with mathematics is you want to be able to apply it to real life. So we're going to start talking about some word problems. And a lot of math problems you've seen can be solved using a formula, but some of them you have to kind of come up with your own equation. The equation won't be given to you. We can, in the context of a sentence or a paragraph, we can make an equation based on some keywords in the problem, and then use the above processes that we've talked about to solve the equation. I'm not going to go through all of this table, but part of writing an equation based on a word problem, based on a sentence, is being able to recognize some key terms. For example, think about what algebraic operation is involved when you say something is more than another thing or greater than another thing. If you see the term greater than in a sentence, you want to think, well, two things are being added together. Or if you see something has been decreased by another thing, then that indicates the mathematical operation subtraction. If you see the word per, so miles per hour, for example, then that indicates division. So being able to pick out what mathematical operation connects two different terms is very helpful when we are asked to write our own equation to answer the question in a problem. So again, I'm not going to go over this whole list, but these are just helpful keywords to allow you to interpret a word problem. So let's use some of these. Let's do some word problems. All right. So the length of, looks like we have a tube. Length of tubing, 40 inches long, is cut into two unequal lengths. One piece is 4 times as long as the other. What is the length of each piece? All right. Picture isn't absolutely necessary, but sometimes it helps. We have some tubing here. And it looks like that tubing is 40 inches long. That's what we're told. 40.0 inches from one end to the other. Okay. And we're told that this tubing has been cut into 2 lengths, and those lengths are not equal. So one is bigger than the other. That's really all that we know. And we're asked, well, what is the length of each piece? We can kind of get an idea of what this question is asking by a little bit of trial and error. Let's just make a guess. Let's see. Let me maybe make the first piece a little smaller just for my my illustrative purposes. What if we did a little bit of trial and error here, and let's just say that first piece was 2 inches. Well, we're told how the longer piece relates to the shorter piece. We're told that one piece is 4 times as long as the other. So if the shorter piece is 2 inches, the longer piece will be 4 times 2 inches, which is 8 inches. We're told that when you put the pieces together, they should sum to 40 inches. 2 plus 8 is certainly not equal to 40. So this is not a good guess. Let's maybe try one more. Let's say that shorter piece is 4 inches long. If that is the case, then the longer piece should be 4 times that, or 4 times 4, which is 16 inches long. So there's some, if you add them together, you're getting it 4 plus 16, which is 20 inches, still not 40. So it's still too small. You can probably get an idea, just kind of guess and check from this setup how long your pieces are going to be. You can see that we're almost to 40. We doubled, if we doubled the pieces again, the length of the pieces again, then we would get a sum of 40. But let's use algebra here. This trial and error can sometimes help us to determine what an equation might look like, should we want to write an equation here. Let's say instead of guessing and checking, let's let the shorter piece be x. Let's just give it a variable name. I'm going to bring in x because that's a common variable. It looks like in order to find the length of the longer piece for the previous 2 guesses, we multiplied by 4 based on the one piece is 4 times as long as the other. So to find the longer piece, we would take 4 times x, or 4x. We're told by this last bit of information that if I were to add the shorter piece and the longer piece, or my representations of those, my goal is I want a length of 40 because my tubing is 40 inches long. So we have an equation now. We can solve the equation for x, and that will allow us to answer the problem. Again, this is a relatively simple example. You could probably just kind of keep guessing and checking and figure out what length your 2 pieces are to fit the context of the problem. But the goal for this is not necessarily can you logic your way through it. The goal is, can you write an equation? Because when we have like a more complex problem, the ability to write an equation will be really helpful. And you're probably doing that in your head, but just to emphasize, equations are helpful. To solve, I have 2 like terms on the same side. I can note that I have a coefficient of 1 on this x. 1x plus 4x is 5x, is still equal to 40 on the right. I'm going to finish by undoing that multiplication to get x by itself, because there's no other simplification that I can do left or right, leaving me with 1x on the left is equal to 40 divided by 5 is 8 on the right. Okay. We don't want to stop there, though. We are asked to find the length of each piece. We introduced x as the length of the smaller piece. So 8 inches is the length of one of the pieces. To find the longer piece, we earlier took 4 times the length. And here we get 32. So it looks like our pieces have lengths of 8 inches and 32 inches, and they do indeed sum to 40. Any questions on that? Okay. The remainder of the problems are going to be of this type. So we're going to do several problems where we're given a story problem, given a word problem, and we're asked to interpret it, write an equation, and then solve that equation to answer the question in the problem. So you're going to see several examples here. For the first one, let's do one about circuits. Why not? All right. In a given circuit, the power is known to be 1200 watts and the resistance is 3 times the current. We want to use the formula below to solve for the current and resistance of the circuit. This one is actually really similar to stuff that we did last time. But it's a lot harder to guess and check than the above one. So let's see here. I'm going to start by filling in what I know. We're told that power is 1200 watts. Is equal to I squared times R. And then we're given one more piece of information. We're told that the resistance is 3 times the current. 3 times indicates multiplication. I see a second keyword. The word is. Seems odd to pick that one out as a keyword, but whenever you see the word is in a problem, it indicates equals. So we could write in an equation here, resistance R is, or equals, 3 times the current, I. So we have a relationship between those two variables, R and I. I think last time we were just directly given this relationship. Here we have to come up with that relationship ourselves. Once we have that relationship, we can substitute it into the below equation for R. So I have 1200 is equal to I squared, and then R we said is 3 times I. Once we've done that substitution, we only have one variable, so we can proceed with solving this equation. I have parentheses, so I'm going to begin by multiplying. 1200 is equal to 3. I squared times I is I to the 2 plus 1 power, or I to the 3rd power. MDOS tells me to do addition, subtraction first. There's nothing left to do there. So I'm going to move to multiplication, division. I'm going to undo that multiplication by dividing both sides by 3. 1200 divided by 3 is 400 is equal to I cubed. Okay. Next thing we want to work on is the exponent. We do have an exponent here. I can undo the exponent by a root that has the same index as that exponent. We have a power of 3. I'm going to undo that with a root of 3. I have to do it to both sides in order to not change the equation any. Cubic root of 400. Let's use a calculator for that one. Cubic root of 400 is about 7.37. I am just going to leave this number in my calculator because while this is one of the solutions that I need to find the resistance as well as the current. This is just the current. So 7.37 is equal to the current. That's one of the things that I was asked for. We solved for the current. We are asked to solve for the resistance as well. And I can do that using the formula I found earlier, how the resistance and the current are related. So resistance is equal to 3 times that current, 7.37, except I am going to use the unrounded version, that version that's still in my calculator, because I might get too much of an error if I don't use the unrounded version. I still have that in my calculator. I'm going to multiply by 3, and I get 22.1, or 10. 22.10 is my resistance. Questions on that? There is a little bit of a margin of error allowed for these problems. So sometimes you can use the rounded version, but I recommend that you lean on the unrounded version, just in case. Okay. Let's do another one. We're going to connect some of the ideas that we've talked about a little bit when it comes to perimeter, area, little bit of geometry here. Let's say we're told that the length of a rectangular frame is 3 feet more than the width. We are asked to calculate 3 things. We are asked to calculate the width, calculate the length, and calculate the area of the frame if we're given this information. We're given that the perimeter of the frame is 86.7 feet. We are given a couple of formulas here. We're given a formula for the area of a rectangle and for the perimeter of a rectangle. We're going to see, in your quiz, you're going to see a couple of problems like this. Today, we're going to see a couple of problems like this, assuming we have time, where you're given a couple different formulas, one for area, one for perimeter, and then you're given a little bit of information about one of those. In this case, we're given information about perimeter. Others, you may be given information about area, and then based on that, you can find the other quantity. So here we're given perimeter and we're asked to find area. But another problem, you might be given area and asked to find perimeter. Okay. So we've got that. And then we have this one statement at the beginning. The length of a rectangular frame is 3 feet more than the width. You might be able to pick out some key terms here. For example, more than indicates addition, just from that chart, you can say that. But you can also do a little bit of trial and error to figure out, okay, how are the length L and the width W related? For example, if the width is, say, 4 feet, then we're told that the length is 3 feet more. Then length is equal to 3 feet more, or 7 feet. If the width is, say, 5 feet, then the length L is, again, it's 3 feet more than, that's what that sentence tells us, or 8 feet. So we might say that if width is W, then the length, well, yes, that is what I want, thank you. If the width is W, then the length L is equal to 3 feet plus W. That's how I could interpret that sentence at first. That doesn't tell us length and that doesn't tell us width. That just tells us the relationship between the two. And we're going to use that to solve. Okay, questions on that before I move on with solving this? Okay. Well, let's see, we're given some information about perimeter. So let's focus on this perimeter equation then and see what that can give us in terms of width, length, and area. We're told that the perimeter of the frame is 86.7 feet. I can just go ahead and directly plug that in. Or P, 86.7 feet, okay? That should be equal to 2 times the length plus 2 times the width. 2L plus 2W. If I have two different variables in an equation, such as these two on the right, I can't solve for a number. I don't know what the value of either of those variables is, so I have to somehow get to where I only have one variable in this equation rather than two. But I think we can do that using this equation we came up above. I think we can substitute 3 plus W for L. So this becomes 86.7 on the left is equal to 2 times 3 plus W. Plug that in for L plus 2W. Now I don't have L in the equation anymore. I just have W. So whenever I only have one variable in the equation, I can proceed with solving that equation, which I will do now. I'm going to focus on parentheses first. 2 times 3, 2 times W. 86.7 is still on the left. 2 times 3 is 6. 2 times W is 2W. I don't multiply it by that extra 2W because that extra 2W is not in the parentheses. So I've taken care of my parentheses. It looks like I have W terms on the same side of the equation. That's the next thing I'm going to focus on is how many variable terms do I have? Looks like I have two. So let's combine them. 86.7 is equal to 6 plus 2W plus 2W is 4W. Add those coefficients 2 and 2. This is a simple equation now. So I'm going to bring in PEMDAS. Think about the addition subtraction. There's a 6 being added to the 4W. Let's go ahead and subtract 6, giving us 80.7 on the left is equal to 4W on the right. I can now move to multiplication division. There's that 4 is being multiplied by the W. So let me do the opposite operation, divide by 4. So we have 80.67 divided by 4 gives us 20.1675. And I'm just going to go ahead and write that down as is. It's 0.7, not 6.7, isn't it? I apologize. 80.7 divided by 4 is, there we go, 20.175. So the width is 20.175, or if I round to 2 decimal places, 20.8. 20.175 is the unrounded version. But in my solution, I'm going to put 20.18. But as you know, this is a multi-part solution. We just found the hardest part, one of the parts. I can now use my other information to find the remaining 2 parts, length and area. So we found the width. That was by far the hardest part. I can now go up above and note that length is equal to 3 plus the width. Therefore, length is equal to 3 plus that width. I can use the rounded version here because I am just adding. So that's equal to 23.18. That gives me the second part. 23.18. And it looks like both are feet. Okay, we okay so far? Generally, once you get that first variable, the others take a little bit of calculation, but not as much. Okay. Now we want to find area.
You're adding 3 to the 20.18, but we're supposed to use the 20.175 or no?
That 20.175, that's the unrounded version. If I were to multiply by that to get another answer, then that's probably a good idea to use the longer answer.
But not
But
on addition.
in addition, the addition doesn't really amplify the error, so it's okay to use the unrounded version.
Okay, thanks.
Yeah, good question. To find the area now, and this is where that unrounded version is probably helpful. I'll go ahead and note that up here. For 23.175, if you want to use the unrounded version. To find the area, I am going to multiply. I'm going to multiply length times width. So I'm going to multiply 20 point, I'll use that 175 here, times 23.175. I multiply those together. I am going to get 467 point, what was it? 20.175 times 23.175, 467.56, it appears. 0.56, and it is in square feet because this is an area. Area is 467.56 square feet. So 3 different things to find here. Questions on that? Okay, and as mentioned, there is a little bit of an allowance for margin of error on these in your quiz, but it is a good idea to get into the practice of using that unrounded solution to find connected quantities, especially if you're multiplying, because that will help eliminate error. Okay. I'm looking at the time. This next problem will not show up on a quiz. It's kind of interesting, but I'm not going to ask you to know how to do it. So it's on the pre-recorded videos for lesson 13 if you're interested in it, but I think I'm going to jump to the last problem for the sake of time because it gives us another similar problem to what we just did that you might be asked to do on a test or quiz. I'll just say C pre-recorded videos if you are interested. I am not going to ask you to know this one for a test or quiz. This one, though, it would be good to do in the 3 minutes that we have, because this gives us kind of the opposite of what we just did. We are told that the length of a rectangular frame is 2 times its width. And then we are given these equations for area and perimeter of a rectangle. But instead of being given information about the perimeter, we're given information about the area. We're told that the area of a rectangular frame is 116 square yards, and we're asked to find the width, length, and perimeter. Okay, I'm not going to do trial and error for this one for the sake of time, but let's interpret that first sentence. 2 times, that indicates multiplication. So we have length, L. Length of a rectangular frame is or equals 2 times its width. So we have this relationship between length and width that we can use. And then we're given some information about area. So I'm going to start with that area equation. Area is 116 square yards is equal to length, which we can substitute 2W for, times width, W. So instead of length in that equation, I wrote 2W. And what that does is eliminate one variable, so I only have one variable to solve for. I can now solve. I have parentheses in this equation. 2W times W is 2W times W is W squared. I I can now undo the multiplication by division. Gives me 58 is equal to W squared. I have a square exponent to deal with now. I can undo that by taking the square root of 58. Let's go ahead and do that one in the calculator, because we're going to use that quantity. Square root of 58 is 7.62. I will leave that number in my calculator. Okay, so W is 7.62 in yards, which means length is equal to 2 times W, 7.62, which if you do that in your calculator, you're going to get 15.23 yards if you use the unrounded version. So we have width and length. Once we have those, we have enough to get perimeter. Perimeter is equal to 2 times length, and I'm going to use probably an unrounded version of that. 15.23, round to a few more decimals, plus 2 times 7.62 is equal to 45.7. 45.7, and it is in yards. And I shortcut that a bit, so I'm looking at the time. Don't want to keep you all longer. Well, that's how you could do one of these problems if, say, you're given area instead of given perimeter. Same idea, just using a different equation to begin. Okay, questions on that? Okay, marvelous. We are done then. That is all. So I hope you all have a wonderful weekend. And I will see you on Tuesday next week. Have a good day. Yes. Thank you very much.
I got a couple questions if you don't mind.
Nope, I don't mind.
Because I'm just kind of lost. Back on one of the practice problems, we had that number 3. I didn't put an answer in chat because I did the whole thing wrong. So when you look at a problem like that, first thing I did wrong is I didn't put the 1 in there because there wasn't a number before the parentheses. But
sorry. I know you told me context, but tell me again, what problem are you looking at?
number 3 on that practice problem, like several pages back.
Okay.
Because we were all supposed to put answers in there, and I didn't get that one at all. I get a little confused of whether to do PEMDAS or the reverse. And then, and then you said something that I caught as you're going through it. So when you're looking at the signs, whether it's negative or plus, or, minus or plus, it goes with the one to the left only. Because I get a little confused about what to do with the signs, and some of them disappear and some of them don't, and I don't. But I don't know. I had a completely different answer on number 3.
Okay.
I wrote it down what you wrote down, but when you started number 3, if you had a 1 in there, is that like -1 times 3?
Yes, that is -1. So the sign to the left of any term goes with that number. So
I gotta write that down.
for example, this negative goes with the 1, this negative goes with the 17, this negative goes with the 2, etc. The others technically do have a plus sign before them, but we don't generally write it unless it's to separate 2 terms.
So you're doing -1 times 3, -1 times 2
Times a -2.
times a -2. Okay, so that one goes together, that goes together. All right, and then if I'm not doing it on a calculator, I don't get the whole thing right, but -1 times 3 is -3.
Hmm.
And then, because you're, on this case, you're actually doing PEMDAS in order, because you are getting rid of the parentheses first.
Mhm.
Um,
Yes, if I'm on the same side of the equation, like if I'm working with terms on the same side, I can just treat PEMDAS left to right. If I am
Okay.
moving things from one side to the other, then I'm gonna do the reverse.
all right, run that by me again. If you're using it on the same side,
So if I'm just considering terms all on the same side of the equation, you do want to treat PEMDAS as you normally would, left to right.
opposite side.
Yeah, so for moving things from one side to the other, or considering both sides of the equation, then you're going to reverse the order of PEMDAS.
Yeah, like I did some of this stuff in my last math class, but you're explaining some of this stuff different.
Mhm.
Um, I don't
Everybody
know.
explains a
Oh,
little bit differently.
yeah, and it just, I don't know if it was a lesson or two before. It's like, I don't know. I didn't get it in my last class very well, but I got it better with you. So
Okay.
I'm just trying to wrap my head around this stuff.
Mhm.
Um, Sometimes when you're doing similar things the second time around, it just kind of, if
Mhm.
the, I don't know, it did this, see, that's what I didn't understand. So I don't remember what that other one was, and maybe I'll think of it when we do our review, but it made more sense on another lesson. So
Okay.
so on this situation, you have all this on one side.
Mhm.
So you're using it with PEMDAS first
Mhm.
until you get it simpler.
Yeah.
So it's -1 times the 3. That's where you got the -3. And then when
Mhm.
you're doing it -1 times the 2, well, that's a -2.
Mhm.
Of course, my freaking pen is running out of ink. On the other part, and that's how you got 2. So you have -2, -3, and a +2.
Mhm.
And then you're doing, then then at that point, that's where you're reversing it, because now
Yeah.
you have, oh no, you're doing the variables first.
Yeah, do the variables first so that you only have have a variable listed once.
So in that case, you have a 5F and then you have a 2F. You're
Mhm.
using the plus sign on that part because the
Mhm.
plus sign is on the left side of the 2F.
Yes, exactly.
Note in here is add. And that's where you got the 7,
Mhm.
but you still have a -3. And then the rest of
Mhm.
it's pretty simple. Yeah,
Mhm.
I got kind of lost on that one.
Mhm.
The other ones were sort of okay. So
Okay.
it's on the same side, you have to get rid of the parentheses. So anytime you see parentheses in a problem from the very beginning,
It's a
you
good
gotta
idea
use,
to get rid of them, yeah.
so you gotta
For our
use it as
purposes. Yeah.
PEMDAS first because there's parentheses in there.
Mhm.
You
Mhm.
can't do anything else until you get rid of that, and then you start going in the reverse.
Mhm. Mhm.
After you get the variables combined, whichever way they are. Yeah,
Yep.
I didn't, so even if there was a multiplication in there and a division, because I know these can get more complicated,
Mhm.
you're still gonna combine the variables first with the sign that's to the left of them, if that's what the case is, before you get it down to the next simple.
We generally do the multiplication division before we do the combining. Um, because the combining terms has to do with addition. which comes, if you're using PEMDAS in the normal order, it comes after multiplication. But the parentheses is essentially multiplication. So we're going to do that first. And then we're going to do this addition of like terms.
Yeah. But I'm saying is, so you did the multiplication.
Mhm,
Well, it's multiplication and the parentheses is kind of what you did at the beginning. But
mhm.
if there were, I don't know, it's probably more complicated to understand because we're just kind of, it might get more complicated in the next chapter because if there was a, say, a division in there like 5f divided by 3, it would be a whole, you'd still have to do the multiplication division to get rid of the parentheses. It all kind of happens at the same time.
We would still do the multiplication division first in that case, yes. And we are going to get to some where it isn't necessarily a matter of combining terms, and there are some where you have variables. Some of the variables have exponents, some don't. And so we do our order a little bit differently there. But a lot of the basic, like foundational elements remain the same, like multiplication and combining like terms.
When you started doing the reverse in this particular problem, though,
Mm-hmm.
it's not until after we got to the 7f minus 3.
Correct.
All right, but technically that's pretty much all you have left is to
Mm-hmm.
is subtraction and then you got to get it down.
Mm-hmm.
Yeah, reverse. It's a different explanation and it helps because in the last class I did, they were like, it depends on the problem, and sometimes you do it this way, and sometimes you do it that way, and sometimes you do it that way, but I didn't get all the concept of all the rules, and she never said anything about reversing the PEMDAS, and we didn't have the
Mm-hmm.
R in there like we're doing in some of the problems in this class.
Mm-hmm.
So I never thought about it doing it. I mean, she never said anything about doing it backwards, and it kind of makes more sense
Mm-hmm.
than what I learned in the last class.
Mm-hmm.
But
And there are, I mean, she's probably was noting that there are other types of equations where it's a little bit more complicated. But if you have a linear equation or an equation with only a variable in a single location, then this is your process.
on some of these problems, I'm skipping the order of operations, and I think that's why some of my quizzes I got to redo is because I'm not remembering the order of operations. I'm looking at it, I'm like, oh, you gotta do this, you gotta do that, you got that, and I get it out of order, and then I get it wrong. Then I'll rework the problem, and I'll figure out like, oh, I just did that one in the quiz before that I missed it. This is the way you're supposed to do it.
Okay, yeah.
But I need to keep it in my head that you're doing it this way because this is the order of operations. And that's where I'm messing up.
Yeah, that's a good way to think about it. Because I mean the idea behind order of operations is we want anybody, no matter who they are, given this equation to be able to come up with the same answer for the equation. So you have to have a specific order in which you do the operations.
Yeah, I mean, mind you, there's some quizzes I'm doing some of those problems and I missed the whole step and I don't even know how it's easy to get lost when you're figuring out this side of the equation
That's true.
and then you're just bringing this number with a variable down and you miss the other half. And I mean, I did chapter 12 quiz the first time. I missed quite a few because I missed the whole step.
Okay. Yeah.
Now, and then I was like, what the heck am I thinking? I'm gonna do this again. Um, you know, but yeah. All right, I'm gonna review this whenever you post it.
Okay.
But thank you for giving me your time again.
Yep, no problem. I'm glad you're asking questions.
Have a good evening.
You too. Have a good night.